How's the dot still there?
I don't know. Just leave it. Whatever. I don't think it. Yeah, it's not showing. Oh, it's showing up there as well. Is it showing up
there?
here?
You can erase it. Erase it, erase it.
That is eraser.
What do you mean stored in picture? Hold on.
Okay. Hello guys, sorry for the delay. We had some technical issues with the streaming setup. So firstly, welcome to GDSC at Heriot-Watt. Thank you for attending today's session to everyone present online. So a bit about myself before we start. I am Gaurav Gosain. I'm a recent graduate with a BSc honors degree specialized in artificial intelligence. I'm part of the core team at GDSC as well. I would like to consider myself as a web enthusiast. Later down the line, we'll be coding something using Firestore. If you would like to follow along, you can scan the QR code. This will take you to a template repository which has some boilerplate code that you would require to start up or catch up with me when I start coding. It has everything from Next.js to Material UI to Tailwind CSS setup, along with other Firebase APIs like Firebase Auth, Firestore, React Firebase hooks, and so on. If you want to read how to set up the repository, you can just scroll down to the readme.md file. It will basically have a step-by-step instruction on how to get the Next.js project up and running. If you scroll further down, the README file even has other information such as setting up Tailwind CSS and Material UI from scratch if you would like to do so yourself. So today's agenda, basically, we start off, we are a bit late, but let's try to stick to the agenda. We start off by a welcoming talk where I just introduce you to the coding structure and how you can clone the stuff from GitHub. We follow that by a recap on APIs and Firebase Auth. We then go on to answer the question, what is Cloud Firestore? And then we discuss why use Cloud Firestore. And then finally, we do a live coding session. And at the very end, we'll actually deploy the web app to Vercel. So Vercel is basically a cloud hosting platform which will let you easily integrate GitHub into your pipeline and deploy your web app to an actual live server. So you can share the link with anyone and they can actually visit your website. So yeah, that's the plan for today. At the end, you can have we can have a short question Q&A session if we have time left for it. So yeah, let's get started. Let's start off with a recap. This is the last session in the series, so let's recap everything we have been through so far. So just as a refresher, we have already talked about the foundations of front-end development. It mainly constitutes of HTML, CSS, and JavaScript. HTML being the content and structure of your web page, CSS representing the presentation or like how your website looks to the end user. Meanwhile, JavaScript actually controlling all the behavior of your website. We use frameworks like React and Next.js, which are JavaScript frameworks. So we'll mostly be looking into JavaScript. You can find great tutorials about HTML and CSS on W3 Schools, which is a great reference. Yeah. So moving on. We also discussed what happens when a user visits a web page. We discussed the concept of a DOM, which is a document object model. We then moved on to introduce what a virtual DOM is, how React works, basically how it first sends out a skeleton, which is not interactive at all, and then later hydrates the page with more interactive components. This not only makes the loading process faster for the user, so that means the user doesn't have to load the entire JavaScript before the React app is actually loaded onto the user screen. So it not only makes the whole process of the loading of the page faster for the user, it also makes the developer experience better. Since the React API is very intuitive, it follows a very similar structure to the DOM. But the advantage of using React is that you can implement JavaScript functionality inside React. Uh, so yeah, we then moved on to talking about components. What is component driven development? It's a very common practice nowadays, using components to build up your web page. So you basically design small components, which are you can assume them something like Lego blocks, and basically join these small Lego blocks together into something bigger that can act as a whole page. You progressively combine them to assemble screens, which the user can then interact with. Following this, we had the whole structure of how Next.js basically parses your code or compiles it behind the scenes. So you can see on the top left, we have developer code, which is basically what we write. As developers, it's JSX, which is a subcategory or special language developed outside JavaScript, which helps us write React code that can then be compiled using the React compiler into something like the compiled code you can see on screen. This compiled code, although it's more efficient than it's JavaScript, so your browser can understand it natively. Uh, but although it's more efficient than your JSX code, it still has a lot of white spaces as well as comments, which are not ideal, since your browser doesn't really need to know the comments in your app, or they don't need the extra white spaces. Remember, whenever we are building web apps, our main goal is to reduce the bundle size. What that means is to make our code as compact as possible so that it can be loaded faster on the end user's device. So that's where the process of minification comes in. Minification is basically the process of removing all the unnecessary code or dead code or extra comments in your code. So minified code would look something like on the top right of your screen. It then goes through bundler, which bundles your code into single files, JavaScript and CSS. And although this bundle is pretty efficient, it can be sometimes big to send as a single file to the end user. So we then split the bundle into multiple small files. This is called code splitting. So yeah, that was a very general overview of how Next.js processes your files, basically. We even talked about client-side rendering and pre-rendering. Now, pre-rendering had different variations. There was SSG, which is static site generation, ISR, which is incremental static regeneration, and there is SSR, which is the most classic pre-rendering approach, which is server-side rendering. We had discussed all these in depth in the previous sessions. You can go back to them and look at them for reference. Now, what's really cool about Next.js is that you can opt into any kind of rendering on a per app, per page basis. So, say you have your landing page, which is a static page. You can opt in for incremental static regeneration, for example, for that page, and it will instantly load for the user. But suppose you say you have like an e-commerce website and you have a products page which keeps updating on a daily basis. You can use something like static site generation or server-side rendering for those use cases. Now, we also discussed what a network was, what different sorts of servers can exist. We talked about origin servers, which are basic servers. They're just static computers that serve assets when a user requests for them. We talked about other types of networks, which are such as content delivery networks or CDNs. CDNs are basically a good way to cache your assets, like static assets. So CDNs can be widespread. They can be distributed servers across different locations. So what happens when a user requests something that's loaded on a CDN, the closest CDN to the user will then serve the assets, which makes the load times much faster than when compared to an origin server, which is not as fast. Now we also talked about the edge. So the edge is a relatively new concept. The edge is a variation of CDN, you can say, but the only difference being it not only serve static assets, it can also be used to serve dynamic assets. What that means is that it is capable of compiling code on the fly. So this reduces the load of the origin servers, making the origin servers do less computation, basically. So yeah, that's a very general overview of what the network is. Yeah, then we moved on to the front end. So we had a full session dedicated to front end, and we made a very basic card component using Tailwind CSS and Material UI, which are two very famous UI libraries. Material UI is a component library, whereas Tailwind CSS is more of a Tailwind CSS can be considered as a utility-based library, which Tailwind CSS is pretty cool, as you can just give particular class names to your HTML or React elements, and it will apply certain styles based on what class names you give to it. So now we also discussed what routing is in general, what routing is when we talk about Next.js, and then we talked about how Next.js handles routing as a file-based system. So what that means is Next.js has a reserved directory called pages, and any file inside pages, any JS or JSX file inside this pages directory is treated as its own route. So basically, it creates an endpoint based on the file names inside your pages directory. For example, if you have hello.js inside your pages directory, when a user visits /hello, whatever is exported in your hello.js file is then rendered on that endpoint. What Pages enables us with is API routes as well. With Next.js, there is an API built right out of the box. You can simply create an API folder inside your pages directory, and inside this API folder, you can then create files which follow a very similar syntax to the file-based routing system. So you can have a hello.js inside the API folder now. And for example, if someone requests a particular request on /API/ hello, for example, for the example hello.js file we just talked about, then the request gets sent to that component that's rendered out in this hello.js file. So yeah, this is pretty cool. So you can simply create multiple files in your pages directory, and Next.js will automatically handle the routing for you. Uh, for routing, we even discussed about certain components like the link component, and if you want to get really if you want full control over the routing on how Next.js works with routing, you can even import a lower level component called use router, which returns a router, and then you can use it for certain tasks such as getting the current path of your website, or you can use it to send user to a different route programmatically instead of actually defining a component. Uh, we also then had a short introduction to APIs, where we talked about a general overview of what an API is, how an API can link back into a front end, how it basically acts as a middleman between your front end and a back end and glues it together. Um, in our case, we'll be using the Firebase SDK, SDK standing for Software Development Kit. So the Firebase SDK exposes us to a web API, which can then be used as part of our Next.js project to then contact Firebase or send requests to Firebase and get appropriate responses. Um, Yep. So this is a very basic visualization of what an API would be like. So you have your backend, that is like where the chefs are, they're cooking. Front end is where you would go in a restaurant, basically ordering something. APIs can be considered as a waiter who can take your order from your front end to the backend, and then can also provide you with a response. Yep. We also discussed about Firebase. So what Firebase is a set of components, or basically different services that Google provides us with. With Firebase, you can do everything, all sorts of application development things, from authentication to storage to having a real-time database or having a cloud database. Um, for the purposes of this presentation and for these sessions, we only looked at Firebase Auth, and today we'll be looking at Cloud Firestore, for example. But there are a lot of other things Firebase offers as services, which are completely free to use to some extent. The free tier on Firebase is very generous. So when you're working on personal projects, it's always a good choice to maybe just prototype something in Firebase, as you won't get charged up to some extent. Um, for personal projects, it's a perfect choice when you want to actually create a quick backend solution. So what is Firebase? Firebase is a mobile and web application development platform. It provides you with various tools and infrastructures designed to help developers build high quality apps. You can create apps faster. It is backed by Google and it's trusted by millions of businesses around the world, big and small. There are a lot of big businesses linked to Firebase that trust Firebase and use them as their primary backend solution. Uh, you get provided with a set of tools that aid you in your software development journey when it comes to backend. You can create applications without the need of server-side programming. Although this is sort of contradictory when we talk about Next.js. Next.js is although mostly about creating everything on the server and using server-side rendering. But the great thing about Firebase is that it also provides you with a Node.js SDK, so you can use Firebase with server-side programming or without server-side programming. Firebase is also generally referred to as backend as a service. So they're basically selling a backend as a complete solution in the form of a service. Then we moved on talking about Firebase authentication. If you followed along the live coding session, we basically even coded an authentication solution where a user could log in with Google and his details would be stored on Cloud Firestore. It had complete functionality included along with logging out and caching. It was a persistent login. So basically, even if a user refreshed the page or visited the page again later, Firebase works in a way that it caches your user's login, so the user is remembered and they don't have to log in every time. Um, the good thing about Firebase, another advantage that you get is that it creates a unique ID for every user. So even if you plan to use multiple authentication methods, for example, we just explored Google login for so far, uh, but uh, but you can use many other service providers like Facebook, GitHub, email, password. You can even have an anonymous login, for example. So what's really cool about Firebase is that it links all types of login platforms to a single unique ID for a user. So say a user can be logged in with Google and the other day decides to log in with Facebook. Both the accounts will be linked to the same user ID, so that the user can have a seamless experience. It even makes the process straightforward for the developer, as we don't have to implement any extra business logic to make it work. So that's a very big advantage. Now, when we look at traditional app development, traditionally what you would have to do is you would have to create a server that's always up and running. You would have to set up your own custom backend solution. You would have to write custom logic so that your front end can basically communicate with your backend and return the data back. You would have to deal with backups. You would have to deal with scaling. So basically, say tomorrow you made an app and it blows up on the App Store, and you want to increase your database size, or you have a lot of concurrent users. Doing that in a traditional sense would be very hard, as scaling databases using a very traditional sort of database is very hard. But when it comes to Cloud Firestore, it has scaling in mind. It was built with scaling in mind. So when it can scale depending on your needs, and it's very seamless. I believe they have automatic data backing as well, so you don't have to worry about your data being lost or deleted anytime. Um, so yeah, this is where Firebase comes into picture. It gives you a very simple API along with its SDK, which lets you interact with all the services that Firebase provides in the backend, which include authentication, storage, Cloud Firestore, and so on. All the other awesome services that Firebase provides you with. Also, as I mentioned before, they have a very generous free tier, so you don't have to worry about reaching a limit or having to pay any money when you're working on small projects. Of course, when you switch over to a bigger project, when you have a lot of users visiting your app, you might need to change your plan on Firebase to be on a pay-as-you-go plan, which again is very cheap and it's very competitive when it comes to database hosting or authentication services. Um, so yeah, now let's talk about the new topic we haven't talked about yet, Cloud Firestore. Cloud Firestore is the sort of backend solution provided by Firebase. It is one of the two backend solutions. They also have a real-time database, which is very similar. So depending on your needs, it might be a better alternative for you to choose. They have a very detailed and an in-depth guide on their website that describes which platform to choose for as your database. Uh, where cloud they almost have very similar features apart from some differences which might be vital to your app. But for the purposes of this tutorial and to keep it very simple, we'll choose to go ahead with Cloud Firestore. Um, the great thing about Cloud Firestore is that it's very easy to integrate with any sort of front-end language. They have SDKs for almost any front-end language you can expect. Um, uh, Another cool feature about the Cloud Firestore database is that you can create a single database and the data can be shared between multiple apps or even multiple platforms for that matter. You can have like an Android app, an iOS app, and a website all using the same database, all referencing the same database. And you don't have to pay any extra money to do that. It's very simple to set it up. And yeah, that's very cool in my opinion. So now let's move on to what is Cloud Firestore. I introduced it a bit before, but to go into the technicalities, it is a flexible, scalable NoSQL database. So it uses NoSQL as its primary sort of backend language. Although you don't have to directly interact with NoSQL, so even if you have zero experience with backend languages like SQL or NoSQL, you can still use Cloud Firestore because it has a very simple API. It's basically just calling a bunch of functions together and expecting a result in whatever language you choose to code it in. Um, yeah, as I mentioned before, you can use it with any platform, mobile, web, and even you can use it on a server because it has a Node.js API. It even has a Go API. So yeah, that's Cloud Firestore in a very brief way. What Why would you use Cloud Firestore is a different story now. Like Firebase real-time database, which is the other database I mentioned a while ago. Uh, which is also a great alternative, don't get me wrong, but Cloud Firestore just provides you with extra features. It keeps your data in sync across all your apps. Your client data is always in sync with your front end. Uh, the really cool thing about Cloud Firestore is that it provides you with something called real-time listeners. So you can basically create snapshots of your database. Now what that means is that it will basically create a sort of a way to always keep in check with the database. So if anything gets updated in the database, the same thing is shown on the front end. So you don't really have to write extra logic in order to synchronize your data with the backend. You can simply use the snapshot or the real-time listeners that Firebase provides you with to have communicate with the backend, and it will automatically update your data, your stale data, so that it can be automatically updated on your front end, and your front end can respond to whenever data in your database changes. What it also helps you is to build responsive apps that work regardless of network latency and internet connectivity. Now, what that means is Firebase also the base SDK of Firebase is very good with caching. So basically, when a user is online, requests are sent to the backend. The results are automatically cached into your browser without the need of writing any extra code. Um, and what the cool part about this is that when a user is browsing your website, say for example, and midway through they lose their internet connectivity, your website doesn't just immediately go offline and all the data is lost. The cache data is still accessible through your front end, which is really cool in my opinion. It reduces a lot of extra code that you would have to write in order for it to be in sync with your database. Um, Also, it has seamless integration with all Google services. You can integrate it with other Firebase solutions and products, including Cloud Functions. You can have Google Cloud be integrated with Cloud Firestore, which is really cool in my opinion. Um, so now, again, why would you use Cloud Firestore? Some other important points to note: it's a NoSQL database, which in general is a key value based database. It's very easy to learn Firestore. You don't have to know any sort of backend programming language in order to be able to use the Firestore's API. Again, it has multi-device support, so you can have an Apple, Android, and web app access your database directly. They have native SDKs for different platforms. You can have a native Node.js SDK, a Java SDK, Python, Unity, C++, Go, you name it. It almost has all languages included. It also provides you with the REST API. I think that's the one we'll be using for this session. The REST API is basically accessible through a client, so you can use it on client-side rendering. If you would want to fetch stuff on your server, you would use something like the Node.js API, set up your own custom Express server, and then you connect it to Firebase or Firestore in this example. Um, Querying is also very efficient with Firebase. The Cloud Firestore database has automatic indexing for most of your data. So it is very easy to understand the syntax when you're querying something. It is efficient, it's flexible, and as I mentioned before, it's also scalable. So when your needs grow, say later in the stage of app development, when you have a lot of users, it automatically scales to your needs without writing any extra code or logic, which is really cool. So to summarize, what are the advantages of using Cloud Firestore? The flexibility being the number one. It's really easy to learn. You can integrate it with any sort of front-end platform, or you can even have an admin SDK. Although we won't be covering the admin SDK for the purposes of these sessions, but it's really cool to know that you can even manage your data through an admin app. You can create your own dashboard app if you want in the future, and you can use the admin SDK to interact with your database with special permissions. Um, it has real-time updates. So as we said before, they have real-time snapshot listeners, which basically communicate with the database, update the stale data so that your user interface or your front end can be updated and stay in sync with your backend. They have offline support. Um, the offline support part is mostly useful when you're developing native iOS or Android apps, but it can be helpful when you're developing web apps as well. Um, it's designed to scale, as I said many times before. Um, it's very easy to scale Firestore as it has automatic scaling. It scales both horizontally and vertically depending on your needs and the traffic your website gets. Now, this is a basic implementation path a developer would follow when they would want to integrate Cloud Firestore SDK into their app. So the first step is just finding out what SDK is relevant to whatever front-end platform you're using, integrate it into your front-end application. You can then define Firebase rules, which is a really cool concept. Firebase rules basically allows you to set certain read and write permissions on different collections in your database. We'll get into detail about what collections are in a bit, but it basically helps you to secure your data as well. So unauthorized users can't read or write data into your database when they don't have the appropriate permissions. Um, you can then add data, which is basically creating new data in your database, get data and modify it, which is reading and updating it, or it can even be deleting the data. So the QR code on the screen will take you to a quick start guide. It's the official documentation of Firestore on firebase.google.com. They have a very in-depth and easy to read guide. So they'll take you step by step into the process of integrating Firebase into whatever front-end platform you choose to use, and they'll also help you get started with basic operations, database operations that might be needed for your app. So yeah, moving on to like a very simple representation of what a Firestore database looks like. So we have data, which is like the primitive part of our database. Data is nothing but information. So a collection of information in Firestore is referred to as a document, and we can group a lot of documents that are very similar into a collection. So we can have multiple collections in our Firestore database. Each collection has multiple documents, and every document has information in the form of data. Um, when we talk about databases in general, there are 4 operations that you would usually do with a database. We refer to these operations as CRUD operations or CRUD, however you want to pronounce it. Now, what CRUD stands for is create, read, update, and delete. It's an acronym for the 4 major operations you do on a daily basis with databases. Now, of course, there are more advanced operations that can be done on a database, but these are the most essential ones you would need to get started. Um, Now, create, as the name suggests, is the operation of creating something, adding a new document. Say, for example, in our case, when we talk about Firestore, when you add a new document to a collection, that's the create operation for us. Uh, Read is basically just reading a document back from the database so that its information can be processed and displayed however you want to your user. Reading can be, in our case, you can read either a single document, or you can even read the full collection if you want. Firebase is really good. Firestore provides you with a lot of other functionality, such as you can query your data. So you can basically set conditions or query data based on particular conditions. You can limit data. You can say that you want only 10 documents, for example. You can even do that with Firestore. Uh, Now, updating is pretty cool. Updating is a very widespread topic, so I won't get into depths with it. But a very basic form of updating would be, say you have created a user's document inside a database, and say the user wants to change his username down the line. So the process of updating or like changing the user's username in the document inside the collection would refer to as updating the database. Now we can updating can be there are more advanced concepts in Firebase such as sub collections. So you can update documents inside a collection that are again inside a collection which are sub collections. We won't get into depths about that. There are more complex data types that Firestore accepts. There are complex objects with arrays inside arrays and objects inside objects. We won't be covering all those, but it's good to know that those exist. You can read more about them on the official Firebase website. They have excellent documentation about all their data types and how the data types can be manipulated, how they can be accessed, and again, it's all uh, it's all described in detail on the Firestore website, on the Firestore documentation. Um, and finally, we talked about create, read, and update. The final operation is delete, which is very straightforward. It's just basically deleting a document, or it can even refer to deleting an entire collection, which is deleting multiple documents at once. Don't worry, we'll be looking into all these more in detail when we get into the coding part. So now, if you had paid attention in the previous live coding session, we basically had a small block of code that actually interacted with Firestore, and it added a new user to the database whenever someone signed in using the sign in with Google button. So that's basically it for the slides. Now let's just move on to actually coding something with Firestore. We can have a look at basic create, read, update, and delete operations. Um, yeah. So if you would like to get the template repository to get like a sort of a boilerplate code from where you could start and catch up to speed with whatever I'm doing right now, you can simply scan the QR code or you can visit the link that's provided in the slide. And yeah, you can either there are instructions in the README file that show you how to clone the repository, or you can even just download it as a zip file. But for today, I would recommend creating a GitHub account because we might use GitHub later in order to deploy to Vercel, which is a basic requirement for Vercel to connect your repository to the website. So yeah, if you're done scanning the code, or if you have any doubts, you can put it in the chat. I'm more than happy to answer. If anyone has any questions, please let me know. Questions? Okay. Okay, so basically, if you go to the link that was provided. Okay, so basically, if you go to the link that was provided in the slides along with the QR code, will take you here, which is basically a repository, a template repository that was created, which has all the boilerplate code you would need. It has all the libraries set up for you. So what you would need to do is click on use this template. So if you already have a GitHub account, you should see this button. Use this template. It should basically prompt you to give the repository a name. So you can give the repository any name for this. I'll just call it Next.js GDSC final demo. And now you can choose if you want to keep the. That's frozen. Sorry. Yeah. So you would see something like this. So some sort of screen like this when you click on use this template. If you're already logged into GitHub, that is. So here you have a bunch of options. You can give a description to your repository if you wish to. You can change the visibility of your repository from public or private. I would keep it public so that everyone can access the code. And then you can basically just click on create this repository. This does everything for you. It should create a clone of the repository for you with everything set up out of the box. So now to clone it, if you have Git installed on your local system, what you can do is you can open your terminal and basically you can basically run a simple command. You can first navigate to the directory where you would want to save this to. So I would go to desktop and I would just do a git clone and just paste the URL that you copied from the repository. And what that should do is it should clone the repository into a folder called Next.js or whatever name you gave. It should basically create a folder with the same name. Now to navigate to that newly created folder, what you would do is you would write something called cd, which changes the current directory, and you can navigate to the newly created directory. And then finally, to open it in code, you can use a command called code dot, which basically opens VS Code in the current working directory. So what that should give you is basically a Next.js project with a lot of files already set up for you. You can see in package.json. It has a lot of libraries already set up for you, including Firebase, Next, React, Firebase hooks, and so on. Now to install all these dependencies on your local system, what you can do is head over to your terminal, navigate to the current directory again if you're not in the current directory, uh, and you can run a simple command called npm space I, which basically stands for npm install. So it will automatically look through your package.json file and install all the required dependencies for you. Give it some time. Depending on your internet connection, it might take a bit to install all these node modules. Uh, Yep, but once the node modules are installed, everything should be set up for your app to go. The only other thing you might want to set up is the environment variables. So basically, uh, you have something called an env.local.example file. So what you would want to do here is go ahead and rename it. So just rename it to env.local and just remove the .example from the end. Now what an environment file is basically it has some unique key value pairs that are not accessible to other people but are required for your app. Um, so if you head over to env.local file, it requires some API keys, for example. Now, where you can get these API keys is if you followed along in the last session when we set up our um, Firebase database and Firebase project. You can simply head over to console.firebase.google.com and I'll switch over to my other account. So yes, so to get those API keys that were required in the environment file, what you would have to do is go to the settings and project settings. And if you just scroll down to the bottom, you would see there's a Firebase config over here. Now what you would want to do is just go ahead and check what they're asking for over here. So if it's asking for an API key, you just grab the API key from over here and simply paste it over here. The second thing required is the app ID. So the app ID is this. You can simply go back and paste it in your app ID section. The project ID example is this. Project ID over there. Storage bucket. Storage bucket is over here. Messaging sender ID. And auth domain. Now, if you see extra fields in the environment file, you can simply remove them from the environment file because depending on how you set up your Firebase project initially, you might have extra or less keys. That shouldn't affect how your project runs though. Yeah. So doing that, now that we know that our node modules are installed, you can simply run a command called npm run dev, which runs the development server for you. Now what this does is starts your Next.js app on a local host port. In my case, I already had a I already had a Next.js app running, so it changed the port for me to 3001. But in general, it should be localhost 3000 for you. So now if you head over to 3001, along with the boilerplate code that was set up for you, you should see that you still have the GDSC sign in with Google screen, which we already did in the last session. So when you click on the login with GDSC with sign in with Google, for example, it should prompt you to choose an account where you can choose your Google account and it should log you in. Wait a second. Okay, I don't think this is updated. Okay, I think we cloned the wrong template. Okay, so if we head over back to the main template, you can see it's forked from my original repository. If you just click on that, that is the more updated one. You can see it was updated 2 hours ago. The main repository should be updated by the end of the session though. But for now, you might have to head to github.com/Gaurav-Gosai/Next.js-template. So what you would want to do is, okay, since we'll need the same environment file, it would be a good thing to just copy this environment file and keep it somewhere. But let's just clone a new template repository. I'll call it Next.js GDSC demo. Again, I'll make it public. We'll have to redo all the steps. Shouldn't take very long. You can simply go to your terminal. I can cd back to my desktop and I can do git clone the repository. I can cd into Next.js demo dot. So now again, we'll have to do the same thing, change the env.local.example file to env.local and replace it with the API keys we got from the previous app, which are right here. And we'll basically have to run the same command again to install all the dependencies in our package.json, which is npmi. So while npmi is installing, let's just walk through the code a bit. So if we head over to the pages directory, so this is where all our main pages lie for our website. So basically, when someone visits the website itself, say localhost 3000, for example, in our case, what they would see is whatever is returned inside index.js file. For now, it is just a big heading saying home, and it calls another component called feed. We look into more detail what feed is doing. Okay, so I think the node modules are done installing. So what I can do now is I can basically stop my previous server that's running. So I can just do Control C to stop that. And I'll run the same command to npm start, npm run dev, sorry, to start my development server, and it should run it on localhost 3000. So if we head over to localhost 3001, and if I refresh, we should hopefully see the new template that was put up today. Yeah, so we see a very basic example over here. Let me just put them together. Yeah, so it's a very basic example with some basic CSS styles applied along with Material UI. So what we have over here is a nav bar. A nav bar is basically just having a logo for us. For example, this is the GDSC logo. In the middle, this is something cool. I'll show you later what this is. This is actually the router's current route. And over here we have our profile image that we get from the authentication. Firebase authentication returns us an image for the user. So that's what put here in the form of an avatar. And then when you click on it, we have basic operations like going to the profile and signing out. We have 3 pages. So we have the home page. We have a dedicated page for posting something. So what this page is used for is writing a caption, adding an image, and you can simply post it to the app. So this is a dummy app where you can just create new posts. We'll make use of the example card we made using Material UI and Tailwind CSS in our previous sessions. And then finally, there's a profile page. So the difference between the home page and the profile page is that on the home page, you'll be able to see posts made by everyone, whereas on your profile page, you'll only be able to see the post made by you. And notice something that how in the nav bar, the name changes based on the route you're currently on. So when you're on profile, it shows /profile over there. If you're on the new post route, it shows new post on the top. And if you're on home, it just shows a slash. So now let's go through how this code is actually working so far. So we have our index.js file, which is what you see right now. It has a basic h1 tag, which is the heading of home you see over there, and it has a feed post, which is not rendering anything right now since we do not have any posts. Now let's head on to underscore app.js file. So underscore app.js file is a very unique file that comes with Next.js, where you can basically define layouts of your app. So what a layout of your app would look like is having a fixed header on every page. So when you have some component that's fixed throughout your app, it's not very ideal to just put the copy paste the component on every single page. So to tackle that, what we do in Next.js is we use the underscore app.js file, which is basically an entry point for every page that's loaded. So we have my app bar over here, which is the top nav bar, and then we have if I scroll down, you can see we have a bottom nav bar as well, which is a custom component that I've defined inside my components. So both app bar and bottom nav bar are custom components defined inside my components directory. So now this is a good way to organize your code. You can have a components directory where you define all the small components that you'll be using later on in your app, so that you don't have to redefine it every time you want to use it. This is basically component driven development. So now let's write some basic code to upload something to Firebase, for example. So in our new post.js file is where we handle everything from taking the input from the user as an image, a caption, and then posting it. So how we save the caption is using a React hook called useState, which basically updates the state every time a user types something. How we handle images is a bit more complicated, and I won't dive into the specifics of how we do it in this session because it's beyond the scope of our project. But in a very general overview, it is basically using something called base64 encoding, which converts your image into a string. And we are using this string to represent our image. Now, in a more professional way, you would have done this using something like AWS or any other online image hosting provider. For example, even Firebase has its own storage provider where you can host your images. But for that you need an additional setup. To keep everything native, I just use base64 for now. You do not need to understand how the base64 conversion works. All you need to know is that your image is basically converted into a string, which your browser can then convert back into an image. Um, so yes, so when you upload something on your when you click on the upload button for this, we are using a library called React. I believe it was called React Drop Zone, which is a library that even allows you to drag and drop files onto your website, which is pretty cool. But you can traditionally just click on the section and upload a file. That works too. So if I head over to desktop and images, let me just upload a random image here. Give it a caption, hello world, for example. But now you see, if you click on post, it will not actually do anything since we have not yet linked Firestore to our app. Um, so if I scroll down to the button, when you click the button, we have a custom function defined for it. So the onClick function inside your button component. So this button component again is a material UI component that we're using. And on click of the button, we basically call something called create post. Um, so create post is a asynchronous function over here that we have defined. Now remember that API calls are not instantaneous. So when you call Firestore, for example, it's not like an instant reply that you get. So to handle that, there's something called async functions. What async is basically it waits for the operations inside the function to complete before it actually ends the function. So over here we can see that we have a simple check over here on create post that checks if the caption is empty. We can just alert the user to enter a caption, or if the image is not uploaded yet, we can alert the user to upload an image. But in case both are uploaded, we can then upload it to Firestore. Okay, so since we are low on time, I would simply copy paste the code from my repository and explain what it's doing. As typing it would take much longer. So if I head over to my private repositories, so if I head over to the same function, create post. So we have a bunch of operations that happen after create post. Simply copy paste it for now, and I'll step you through the code line by line. Uh, so what's happening over here is it first sets uploading to true, which is just a state we have created. So what setting uploading to true does is it disables the button until the post is actually uploaded to Firestore. Now after that, we define a document reference. So doc is a function that Firestore provides us with. It basically creates a new document, or in more technical terms, it returns a reference to a document. Um Then we can pass into the document we want to select. So we want to select in our database. So DB is actually the thing that we exported in our Firebase config file. So we are selecting our particular DB, and then we want to create a collection, or we want to select a collection. So what's cool with Firestore is that if you do not have a particular collection, it will create it create it on its own. So it selects or creates posts, which is a collection for us, and it returns a reference to it basically. So it creates a temporary document and post and returns a reference using this line. Following that, we have a simple object over here, a JavaScript object that we have defined. So we are defining certain fields in the object. For example, we are saying post ID is the ID from the document reference being the reference we just created for our particular collection. Now caption again is the string or like the variable in which we are storing the caption when the user types it. Image here is the base 64 string, as I described, as I told before. We won't be going in depth about how the image is actually working, but it's important to know it's a string, and the string can be used to actually send data over to Firestore, and then can be retrieved back and rendered back as an image. Created at is a variable we would use uh, just to save that what point in time was the post actually created from the client side. Uh, Likes is an array, and usually likes could be a number as well, but in our case what we're doing is we are creating an array of likes. And what this array is basically an array of all the unique user IDs of everyone who likes the post. uh, so we'll have an array with multiple user IDs, and the number of elements inside the array is equivalent to the number of likes. So we can use likes in a way that we can just call likes.length in JavaScript to know how many people have liked the post. What this helps us to do is it also helps us keep track of which user has liked the post, so that we can render out, we can update the user interface in a way that reflects the correct state of the post given a user is logged in. Now we also pass in a small user sub object inside an object, which again has some basic properties such as the user ID. It has the display name, the email, and the photo URL. All the information that's passed here is essential when we render out our card component later, because remember, it had an avatar, it had like a name on top. And the user ID is just good in general to verify which user had actually posted this post. Now moving on to setDoc, which is setDoc is another function that Firestore provides us with. So what setDoc takes is a reference to a document. So basically we are referencing a document and we are setting its content to a particular value, which in our case is a post. So the post custom object that we defined above is simply passed into setDoc, and setDoc would automatically set the value of the temporary reference that we created uh, to the values inside post. And after all that's done, so what this await keyword basically does is waits for this function to complete. And when the function is complete, it sets the uploading value to false, basically telling our front end that the uploading process is complete and it can stop disabling the post button now. And finally, it uses router.push. So we had explored this before when we were talking about routes. Router over here, if I go on the very top and see where it's defined, it's using use router, which is a hook that's provided by Next.js. What use router gives us is very fine control over the router. So what we can do is something called router.push, which basically redirects the user to a particular page without actually refreshing the page. Um, yeah, so we are pushing the user to /profile where they can view the newly uploaded post. So to see this in action, what we can do is, since we have already uploaded a caption and an image over here, we can simply click on post. And there you go. It uploaded something, but we still don't see the changes reflected on our profile page. But to verify it actually worked, what we can do is simply head over to Firebase and we can go to the Firestore database. And if we look at the collections, although we didn't create any collection manually, Firebase is smart enough to create the collection if it does not exist. So inside the collection, we have a document with a unique ID that we didn't have to set. That's the great thing about document. The doc function from Firestore, it automatically creates a unique ID for us, so we don't have to worry about creating a unique ID for each post. So yeah, it created a unique ID over here with all the information as expected. You can see there is a caption created at. Now you would notice the created at over here is a number. What this number basically is a Unix timestamp, or it's even called an epoch. So a Unix timestamp is basically the time in milliseconds converted based on the Unix standard of calculating time. Now the image over here is our base 64 string. As you can see over here, it specifies base 64. Likes is an empty array since we didn't pass any values. So basically, initially when we create a post, there won't be anyone liking the post. And we save the post ID inside the document itself so that it's easier to reference. Following that, we have email. We have the user object, that the sub object that we defined, which contains the email name, photo URL, and the unique ID of the user. So now this was how we create something. So we covered the create part of the CRUD operations over here. Now let's move on to the reading part. So since we have a very small app, I wouldn't recommend this in an actual production app, but since we have a very small app, what I would do is I would read the entire post collection inside our underscore app.js and basically pass it to every single component in our app, so that our data is accessible throughout the app. So now how I would do that is right now I have an empty array of posts, but instead of doing something like that, let me just grab the code from my repository. So in my underscore app.js, you would see that I'm using a query on the post. So I can simply copy this from here. Don't worry, all the code will be available. So even if you can't follow it live, you can head on to the Tech Club repository later, and all the code should be uploaded there. You can even visit my personal GitHub profile, and you can see the repository over there. So to explain what this particular line of code is doing is that it's using a React Firebase hook. So if you remember, we used the use auth state hook before, which was a React Firebase hook. So what React Firebase hooks is basically a library that makes certain operations simpler by defining certain standards. So what this use collection data is doing is that it returns you everything inside a collection. And the advantage of the use collection data hook is that it's a real-time hook. So basically, whenever something is updated in the backend, the same changes are reflected on your front end. So inside this use collection data, you have to pass a query. So a query in Firebase is basically what sort of data you're trying to fetch, or what conditions you want to put on the type of data you want to fetch. For the first argument inside the query itself is the collection that you want to reference. So. Oh. Yeah, so the first thing you would want to reference is that yeah, so inside the collection, we are referencing the current database. Order by is another a function that Firestore provides us with. So basically what we are saying here is we want to order all our posts in the descending order of the date it was created at, which is usually the functionality you would want. So just assume that you have multiple posts. You would want the newly created post to appear on the top and the old ones to appear at the bottom. That's the reason why we call it in descending order over here. So basically doing this should now, yeah. So if you visit your profile now, you should see that the post was created successfully. So yeah, this is the reading part of the CRUD operations. It's a very simple example. Obviously, there are more things you can do, such as instead of order by, there are other things where you can use where queries. Where queries are basically you can compare a particular field in your document with something else. Um, yeah, there's something called limit as well. So in our case, since our app is very small and it's like a toy app, we're not really bothered about performance. But when you want to scale your app up and when you have, say, thousands of posts, you wouldn't want to just call the use collection data and get all the posts at once, because that will be really hard for your website to render. So there are concepts like pagination, for example, pagination, however you would like to call it. So that's the concept of displaying a certain number of posts at once, and then when the user wants to go to the next page, you fetch the other posts and then display those. Uh, Firestore supports that out of the box. They have something called limit and start at and start end at. They're different functions that can be used to limit the number of documents you fetch, or at what point you want to start fetching your documents inside your Firestore database. So basically, yeah, that was the read operations. Now moving on to the update operations. If we head over to the custom card.js file, this is where we have defined the card. The post, basically the card here I'm referencing is actually the post. So inside the post we have the like button, which right now won't work. It doesn't have any functionality. But what we want when someone clicks on the like button is basically add that person's unique ID to the list of likes for that particular post. So how you would do that is by, so if I head over to the components folder over here, and if I go to custom card.js, you can see update likes is a function over here. So what this is doing is, again, it's using doc to get a reference to the post. We have post ID over here. I think I have to charge my laptop. Just a moment. I don't think you can see it anymore. Yeah, so I was referencing to the doc function over here, which is a Firestore function. It basically gets a document from a particular collection in your database. The third argument over here is actually the ID you are referencing inside the collection. So inside my post collection, I want a particular document with the post ID. Um, so notice in the previous part, we didn't have the third argument. So when you do not pass a particular ID, Firestore is smart enough to create its own reference, give it a separate ID, and return you to the reference to the new document. But when you pass a post ID, or when you pass any ID, a third argument basically inside your doc component, uh, Firebase will reference that particular doc for the ID you have passed for, and it will return that as a result. So over here, what we are checking for is if the likes, the current likes array, if it includes the user.uid. User.uid is the ID of the user that's currently logged into your app. So if you're liking a post, and if the post likes array already includes your user ID, uh, it will remove the ID from it. So basically you're unliking it. If it's already liked and you click on the like button again, it should unlike the post. And otherwise, if it's not already part of the array, it basically adds it to the array. So array remove and array union are two functions that Firestore provides us with. Array union is basically adding something to an array. Array remove removes it from the array. Um, so now if I go ahead and click on the like button here, you can see the like button changed over here, and the count of the likes also updated over there. Now this is real time. So if I actually go ahead, create, so not charging. Can't charge and screen mirror at the same time. To explain here is so if I have two instances of my same app together, and say, for example, I sign in with a different account on here. Since it's in incognito mode, I don't think it'll have any account. Let me just log into a different account. Okay, so if I approve that, yep, basically on the home page of the other user, you can still see the post. It's made by a different person. And you can see it's liked on the left hand side, but it's not liked on the right hand side. But as soon as I like it over here, you can see on the left side the like counter increased to 2. And in a similar way, if I reduce it on the left side, it reduces on the right side. The like counter on the right side also reduces. So yeah, and you can post from the other instance of the app as well. So let me just give it a caption, new post, and let me just select a different image, for example, and post it. So you can see if I head over to the home page, you can see the post was made by some other user. Uh, so basically, any user can post, and it should appear on the home screen. But on the profile screen, or basically on your home profile, you only see the post made by yourself, which is the expected functionality. Now this was the update part of the CRUD operations. Moving on to the delete part. Uh, Delete is pretty simple. So basically what you can do is um, so delete doc is another function that Firestore provides you with. Delete doc is basically um, it takes a reference to a document and simply deletes it. There is a delete collection function as well, but we won't be using it right now. So what delete doc takes is a single argument. It's a document's reference. So what you could have done is you could have extracted this into a separate reference variable and then use the variable. But to make it concise, I've just referenced the doc inside the function itself. What it is doing here is it references the DB, which is our database. It goes to a particular collection posts, selects the post ID, the current post ID we are at, and it deletes the document. So now to see that in action, we can just head over here. And if you notice, let me head over to the home page on one of these instances so you can see it in real time. So if I am on the right hand side, you can see that I have only one post right now, and the left hand side user can see it as well. But as soon as I delete the post, it should update in real time, and the left hand side user does not see the post anymore. So that's one advantage of having a real-time database. Everything updates automatically. You don't have to take care of any logic to update the code manually or update the UI based on the code. Since the same variable gets changed behind the scenes, everything is handled automatically. Now, since we are done with the create, read, update, and delete operations, this was a very basic overview of it, and I'm sure there are a lot of concepts you still don't understand. I would recommend going to the official Firestore documentation, going through all the data types they have to offer, all the different uh, functions they have that you can call, and basically trying out your own mini version of something. You can create your own app. You can add functionality to this app. All the code for this will be open source, by the way, so you can go ahead, play with it, change it, publish it, whatever you want. That's completely free to use. Um, so yeah, you can implement so much over here. You can create user roles. You can have admins. You can have different. You can have a following feature. Basically, you can go to someone else's profile. You can follow them. You can add search functionality. It's just a few ideas you can do in the future. But this should set a baseline for you on how you can go ahead and approach something. It's not really a tutorial to teach you how to use Firestore. It's more like these are the operations available with Firestore, and this is where you can find it. So basically, you can find it on the official documentation. It's a great resource, and you can try experimenting. There's nothing that can go wrong when you're developing on like small projects like these. So basically, the last step over here, we would finally deploy this app to an actual website that we can share with others. Uh, Now, how you would do that is, firstly, if you're using VS Code, it has a it has Git functionality built in. So you can just add a commit message, add something meaningful. I'm running out of time here, so I'm just going to add any message, and you can basically push your commits back to GitHub. Um, so yeah, so I have pushed all my commits back to GitHub. Now, what you would want to do is go to Vercel. Uh, Vercel.com/new. So over here, you can connect Vercel with your GitHub account. So you can simply click with continue with GitHub. It should take you to a different screen to authorize that you want to authorize Vercel to use GitHub. Once you have done that, you'll be presented with all your repositories on GitHub. And it automatically detects what sort of package.json you have. So it automatically reads it and figures out what kind of app you want to deploy. So in our case, I think the repository we were working on was called Next.js -GDSC demo. Um, so that's the first one that shows up. We'll just simply click on import. It takes us to this screen where we can give a particular project name. For example, you can change the project name over here. I would keep it the same for now. Now they have a bunch of presets. So Vercel, you can use Vercel for hosting like normal JavaScript or HTML or Jekyll or whatever framework you're using. They have a bunch of options, or you can even set up your own hosting options. But Vercel is the creator of Next.js, so they're basically the company behind Next.js. So they have the best support for Next.js. They have all the optimizations done for Next.js. You can simply click on Next.js over here. Root directory. Now, in case if you had different files in your root directory and your Next.js project was located somewhere deep inside your repository, you could also change the root directory that you would want to use. But in our case, since it was the root directory, we would not touch that. Now there are other settings you can change. There are build commands, output commands, install commands. These are a bit more advanced. You would not want to use these in most cases, but they are there for your convenience. Now, environment variables is something that we'll have to add, since the environment variables are not really accessible to Vercel. We'll have to manually copy paste all these public keys into our Vercel environment variables. So I'll quickly do that. So that's our first environment variable. In a similar fashion, you'll just copy paste all the other environment variables. Um, So now why this is necessary is that these are all the variables required for Firebase to work. So if Vercel doesn't have access to all these variables, Firebase would not be initialized properly, which will cause problems uh, when you actually host the app and run it. Uh, so it's a good practice to keep all your environment variables on Vercel updated. Great thing about Vercel is that it supports continuous integration and continuous development, basically CI/CD. Now, what that means is whenever you update your GitHub repository, basically whenever you push changes to your GitHub repository, Vercel will automatically check for changes. If it sees anything has changed, it will rebuild your entire app with the extra changes. Suppose you added more components in your web app, or you added more dependencies, it will automatically build your app, add all these dependencies. So I've added all my environment variables here. So all you have to click is deploy. It's as simple as that. Vercel automatically detects it as Next.js, so it will handle all the building process for you, uh, giving domains as well. Vercel has full support for custom domains. So if you already own a domain, you can simply link it here. Very easy, like a couple of steps. You might have to change DNS addresses on wherever you bought the domain from, but it's a couple of steps. It's very easy to understand. So we can see it's building right here. We get a few warnings, but those are image tags. So Next.js has their own image tag built in, but it's not really optimized, so I didn't choose to use it right now. But they recommend you using their image element. So you can see it compiled successfully. Now it will build your app into something that's near static, so it can be deployed really quickly. You can see it deployed your app just as simple as that. Now you can click on that and you should see you have a custom website that anyone can visit. I have dark reader, so the CSS looks a bit weird. But yeah, so you have basically deployed your own web app. You can access it. One last step you might want to do is in your Firebase database, you haven't really told Firebase that you'll be using a particular domain. So whenever someone tries to access it from somewhere else, it rejects all your requests. So to fix that, you can go under authentication. Uh, and in authentication, inside settings, you'll see authorized domains as a section over there. It has localhost by default, which is where we develop our stuff, and it gives you other URLs that can be used with Firebase hosting. But now since we have deployed it and we have a ready to go URL, what we can do is simply go back there, add a domain, and it should do the rest. It should automatically give the permissions for that domain. So now that we've given that, let me just refresh to make sure the permissions are updated. And if I click sign in with Google, again, it works as expected. Sign in with Google. I click on the account I want to use. And there you go. You have deployed your app to an actual browser. Anyone on the internet can visit that particular URL and they will be redirected to this app. Um, so yeah, I would call that a wrap to the session. That was it from my side. If you would like to know more about Next.js or want me to host further sessions in the future for more complex topics, or maybe not even related to web development, anything in general, feel free to drop down your recommendations on what you would like to see next. Yep, this has been GDSC Heriot-Watt. If you have any questions, please drop them down in the comments. I'll be more than happy to answer. And yes, that's it from my side. Thank you very much for attending. Okay, I see someone has asked for the GitHub link in the chat. So you can basically scan this URL, or you can visit the link that's given there. Uh, that should take you to the template repository. The repository with all the code, I'll open source. It's already open source, so you can basically just go ahead to github.com/Gaurav Gosain. And if you head over to all my repositories, uh, it should be the first one over there, Next.js GDSC demo. Yep, that's basically it. Does that answer your question? I don't think I have any other questions in the chat. So that's it from me now. So again, thank you so much for attending. It was a great time hosting all these sessions. Hopefully you learned something new from this. That will get you more into web development in general. Yep, that's it. Thank you so much.